Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyworld.it/Jedi. My advice on how to pass actuarial exams is at smartyworld.it/pass. This video channel is at smartyworld.it/pass actuarial exams. Information about online seminars for exams P, FM, IFM, and LTAM that I run is at smartyworld.it/btdt-online. You can find information and purchase my study manual for exam P at smartyworld.it/btdt-p. For exam FM manual, go to smartyworld.it/btdt-fm. For my IFM manual, go to smartyworld.it/btdt-ifm. And for my LTAM manual, go to smartyworld.it/btdt-LTAM. I direct the Actuarial program at Illinois State University. You can find information about it at smartyworld.it/actuary. If you would like to offer tax-deductible donation to support our students, please go to smartyworld.it/help ISU Actuary. Here's a problem for today. For exam P on probability, let each of the independent random variables x1 and x2 have the density function f sub x of x equal to e to the minus x for x between 0 and plus infinity and 0 elsewhere. What is the joint density of y1 equal x1 and y2 equal to 2x1 plus 3x2 and the domain on which this density is positive? Here is the solution. Note that y2 is equal to 2y1 plus 3x2, which is greater than 2y1, as x1 and x2 are both positive. Thus, the region of non-zero density for y1 and y2 is where 0 is less than 2y1, less than y2, less than plus infinity. The transformation we are considering is y1 equals x1, y2 equals 2x1 plus 3x2. We need to find its inverse to find the joint density of the transformed random variables. Well, the inverse is x1 equals to y1 and and x2 equals y2 minus 2x1 over 3, which is the same as y2 minus 2y1 over 3. And we can write this as minus 2/3 y1 plus 1/3 y2. Therefore, the Jacobian of the transformation is the consisting of partial derivatives, partial derivative of x1 with respect to y1, a partial derivative of x1 with respect to y2, partial derivative of x2 with respect to y1, and a partial derivative of x2 with respect to y2 is 1, 0, negative 2/3, 1/3. And the determinant of that Jacobian matrix is 1/3. And of course, the absolute value of that is 1/3 as well. So we know that x1 and x2 are independent, so that the joint density of x1 and x2 is just the product of marginal densities, which is e to the minus x1 times e to the minus x2, and the joint density of y1, y2 is just the joint density of x1 and x2 applied to x1 that corresponds to that y1 and y2 pair, and x2 that corresponds to y1 and y2 pair times the absolute value of the determinant of the Jacobian matrix. And that is equal to e to the minus y1 minus y2 minus 2y1 over 3 times 1/3. And that's 1/3 e to the minus y1 plus y2, the whole quantity over 3. And that's answer E. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.